Many times when you're working through stoichiometry problems, you're going to be asked to find an amount of solid produced, which is typically your theoretical yield, and then I'm going to ask you to do a lab in which you're going to be finding your actual yield. So what this is this is kind of a background to different labs that you might do, and these are the types of calculations that you're going to see in the lab. So in this example, you have two solutions that you're mixing together. You're mixing together 75 milliliters of 0.3 molar zinc iodide to 125 milliliters of 0.45 molar silver nitrate. And the problem asks how many grams of the precipitate is formed. So before you can figure out what the precipitate is, you have to write your overall balanced equation. So if we take a look down at the bottom, I've already written out the formula. We have the zinc iodide, which is aqueous, the silver nitrate, which is aqueous, because the problem tells us, reacts to form silver iodide, which I know is a solid because it's insoluble if you look at your solubility rules, plus zinc nitrate. I know that zinc nitrate is aqueous because anything that combines with a nitrate is always soluble. And so this is our molecular equation, right? This is our overall balanced equation that we look at for the stoichiometry. Underneath this, I want you to now pause the video and write the net ionic equation for this reaction. What you can look at now is underneath both reactants, I included the given information from the problem. I would recommend doing this, especially when you're given a lot of information like in this problem. So I wrote 75 milliliters of 0.3 molar and 125 milliliters of 0.450 molar. Now, whenever you have stoichiometry, you're given amounts, and you have reactants, always go to moles. So to start off this problem, I would take your volume, put it into liters, your molarity, find moles. Same thing with the second reactant. Now notice you have amounts for both reactants. That tells you you're going to have a limiting reactant problem. So you're going to have to figure out which reactant is limiting, which is excess, and then go from there with your calculations. So if we look at this equation, I recommend using a BCA table as you work through. Again, especially with limiting reactant problems, BCA tables are easier to organize information. You don't have to, but I'm going to for this example. So I just rewrote the balanced equation on this board, and underneath the reactants I gave the initial amount, and then I wrote the calculation for the mole already in the before row. So when you multiply these together, when you convert 75 milliliters to liters, multiply it by the molarity, you find that you have 0.0225 moles of zinc iodide before the reaction takes place. And then the same thing with the silver nitrate. If you solve for moles using the given information, you find that you have 0.05625 moles of silver nitrate. Now, if you look in the before row for both products, you have 0, right? You don't have any moles of products before the reaction starts. Now, we have amounts for both reactants. We have to figure out which one is limiting. If you take a look at the mole ratio, it's a 1:2 ratio. You need twice as much silver nitrate as zinc iodide. If we look at our moles of zinc iodide, okay, if we double this, it's about 0.45. We have that and more, okay, which makes this silver nitrate our excess, and that makes the zinc iodide our limiting reactant. So the zinc iodide is our limiting reactant. That means we use up all of that in this reaction. And in the change column, you notice that I use the amounts based on the zinc iodide. So if the zinc iodide is my limiting reactant, I use up all of that in the reaction, and I end with 0 moles. Now, if you look at the silver nitrate, you notice that it's 2 times 0.0225. Well, the reason that it's 2 times that is because for every 1 mole of zinc iodide, you need 2 moles of silver nitrate. So you use up twice as much silver nitrate in this chemical reaction, which means the after, I'm going to take the amount that I started with, I'm going to subtract the amount that was used up, which means after the reaction, I have 0.01125 moles of silver nitrate left over. Now I'm also going to determine how much of each product that I form. if you look at the zinc iodide to silver iodide ratio, you notice that it's 1 to 2, very much like the silver nitrate. But instead of using up those moles, we're actually creating, right? You're forming that silver iodide, so this value is going to be positive. So you're going to be adding 2 times 0.0225 moles, and we get 0.045 moles of silver iodide that we form. If we look at the zinc nitrate, we're only forming 0.0225 because it's a 1-to-1 ratio with the zinc iodide, and so we make 0.0225 moles after the reaction. Now the problem asks how many grams of the solid do we produce. So from the BCA table, remember whenever you plug anything into the BCA table, it's always moles. So from this value of moles, we can go to grams. So I have 0.045 moles of silver iodide that I make in this chemical reaction. I'm going to multiply it by the molar mass. Okay, I have moles of silver iodide that I need to cancel, so moles go on the bottom. For every 1 mole of silver iodide, it's 234.8 grams. Add those up, add up the masses on the periodic table. It's 234.8 grams. If we multiply across, we find that in this chemical reaction, we form 10.6 grams of silver iodide. So if you were performing a lab and you were performing this exact reaction, your theoretical yield would be 10.6 grams of silver iodide. What you could do then is you could compare how much you collected to this amount, and you could determine your percent yield and figure out how close you were to what you were supposed to get.